Cameron has been involved in robotics and automation from a lot of different sides, from the factory side, from now the automated vehicle side. And two of my favorite things about Cameron, number one is I just learned that he played Ultimate Frisbee while training for the UFC swim team. I'm a big Ultimate Frisbee fan. And two is that he's giving this car away to a raffle.
Best question.
Best question that is asked. That second one I might have made up, but anyway, a round of applause for Cameron.
Thanks for coming out too, and thanks for the great introduction there, Greg. So, again, my name's Cameron from AutonomouStuff. I'm a regional manager or business development manager here in the Silicon Valley. Been with AutonomouStuff for 7 months or so now, and very formally at Velodyne, with my good friend Michael there in the audience. So, and really there's great parallels. We still distribute Velodyne, and really that was the good intro into the automotive business for me from industrial. So AutonomouStuff is a quickly growing company. I guess you could say we sort of started out as a distributor and then evolved into an integrator and now kind of a technology partner and provider for companies that are these Chinese EV companies you're talking about, small robot developers, drone developers, tier 1 automotives, even OEMs in some cases. So our goal from the very beginning was to really enable the future of transportation autonomy and help speed that up. So our founder, Bobby Hambrick, back in 2010, and Bobby actually came from the same background as myself, even the same company. He was a technology specialist for a German company called SICK, working for a distributor called Springfield Electric. And in those roles, we're dealing with a lot of small robots moving things around factory floors. So in that experience, learning about LiDAR and navigation within buildings, he's like, well, maybe we should start a distribution company focused exclusively on navigation products. So cameras, LiDAR, radar, GPS, IMUs, all these things you need to safely move stuff around outside factories. So from there, he started that business in 2010. And after about 4 or 5 years, as they were giving these products to people in this business, decided, well, geez, all these people are asking us, well, can you help us build a platform vehicle? It's really difficult to create a by-wire interface for these cars today because the Dbc files that are used to do that are highly secret. So, and I'll get into how we did that in a little bit later. So that was the kind of goal from the start. And then with the advent of the platform, we really brought together these products, services, engineering, integration, to really keep pushing along the process of adopting autonomy in a wider market. So we don't really consider ourselves in that race. We're the people providing the shoes for the racers. That's a good way to think about it. So we're a very young company. We're headquartered in Norton, Illinois. It's a very flat and gorgeous town just east of Peoria. If you know Peoria, Illinois, that's where Caterpillar is. So we do cherry pick lots of great engineers from Caterpillar who are already used to automating giant tractors and things running around mines. This has been a business that existed for many years already. So, but of course, when you move from a mine in this very controlled environment onto the road, things get a lot more difficult. So, again, founded in 2010, we've got well over 2,000 customers at this point in time, and we're certainly worldwide. I think we're almost sharing most of our time between here and China right now. And really, that's the development centers. China is going crazy with how much investment is going into autonomy right now. Europe is a little more difficult to deploy these types of vehicles on the road in Europe because of TÜV. I can't import a vehicle like this that's already enabled by wire into Germany. I can certainly send one there and fix it after it gets it. So we do grow quite aggressively. We're kind of tripling in size every year. And this office in Silicon Valley just opened. Well, it's not even really finished yet. We'll do an opening house probably in September sometime. So moving quite quickly. So who do we deal with? Of course, the automotive tool chain. So if you're a tier 1 automotive sensor supplier and you want to start developing sensors specifically for autonomy, you might want a car to do that on. You might want to have that car also be able to be driven by wire. So customers like Mobileye and Delphi who want to start developing things around autonomy reach out to us. Agriculture is another entrant where precision agriculture has existed for years based on GPS. We're augmenting these tractors with radar, with LiDAR, to kind of increase the safety as they operate, and also to give them more awareness inside the field to help them do their jobs better. As well, mining, of course, we've been working with Caterpillar, the military, aerospace, and a ton of startups. So the startup environment in the Silicon Valley, as always, is extremely dynamic. It seems like we find a new kind of mobility-slighted startup every couple of weeks, and the pace doesn't seem to be really slowing down. So we find even big companies like Baidu, spurring startups all over the place. As soon as someone leaves there, it seems like a week later they've got a new company going, and they're calling us for another car, which is great. Maritime is quickly developing too, and even railroads. Of course, in the university space, we're seeing growth of engineering schools developing autonomy classes to kind of address this needs in the marketplace. So I was recently driving Governor Brian Sandoval around in this car at the University of Reno, Nevada, to a bill signing where he was endowing $87 million for a new engineering school at the University of Nevada for our autonomy, so autonomous buses, autonomous cars. It was the first bill signing in US history where the governor was taken there with an autonomous car. It was exciting. So it got him there very safely. So anytime I'm giving someone a ride in this thing, it should be extremely uneventful, unless we're on the racetrack or something. Typically, it should be. They shouldn't even know that I'm not driving. So the applications we get into, of course, autonomous driving cars and trucks. I think trucks are quickly taking over the market a little bit for us. It seems like people get a few cars and they're all right, the next thing we want is a semi-truck. And they're bending to the wind of where they think investment money might be coming from and where the early adopter sort of industries might be. Long-range trucking on the highway seems to be one of those. Equally with shuttles, when we have vehicles moving around they're doing the same route, whether that's a mail truck or that's taking around a college campus. These are very easy applications, but a little easier to deal with than driving through downtown San Francisco at rush hour. Convoys, of course, is a big thing with Peloton. And then in robotics, we're dealing with robots that are going faster and flying and all sorts of other applications. That's usually LiDAR-based. 3D mapping is a huge piece of this equation too. There's a big school of thought driving that you must create a really quality 3D map, HD map, that you're going to then localize your vehicle with a similar LiDAR technology that the map was derived with. And so there's a big growth of companies that are just driving all over the place, mapping everything, annotating it, and then either delivering that to an OEM, in a lot of cases the OEMs are doing this on their own. So of course the artificial intelligence piece, that's another driver, especially with this NVIDIA Drive PX. That's NVIDIA's goal, is to create this AI kind of enabler for researchers who use graphics processing to do deep learning and develop smarter cars. So we're obviously a huge marketing company. For a company that's only 45 people, we make a big splash. So we attend a ton of trade shows and meetups and stuff, so we're always out there trying to make noise and trying to just kind of support the industry and, again, accelerate it and make sure people are thinking about it. So what do we provide? Of course, the platform vehicle is now the kind of foundation of our business. So the Lincoln MKZ and similarly the Ford Fusion were our first vehicles that we released onto the market. And basically, this car is enabled to be driven by wire through a partnership with a company that, an ex-Ford person left with Dbc files, the secret sauce for controlling the vehicle. So this has sort of a Dbc translator that interfaces between the computer and the drive system of the car. And that's the kind of core of creating an interface to be driven by wire. And then the next thing you're going to want is outfitted with sensors. So we're going to put different types of perception kits. Nothing is the same. We're not a cookie cutter company. Everybody wants some different take on sensors and cameras and computers. So it's all over the place. Yes? Oh, yes. So the Dbc file, if you're not familiar, is a set of commands that are really telling the vehicle, or it's the language the vehicle speaks. So if I'm telling the steering wheel to turn 30 degrees to the left, there's a specific command set that does that. And those are highly secretive for many, many reasons. I've talked to the directors at Mercedes that say, I don't even have access to these because I can create a robotic car that someone can do something nefarious with. Or, you can imagine the potentials there. So they're highly guarded. And the fact that our partner was able to get out of Ford with these is somewhat questionable, but Ford is. But the result of it was we've created a whole industry around bringing easier autonomous development to startups, where otherwise you would have a bunch of people hacking them, getting incomplete command sets, and not having a really safe solution to deploy. So of course, safety is a big deal when we're driving down the road at 80 miles an hour. So using those OEM commands makes it a lot safer. And then products, and I'll get more specifically into what we were doing with LiDAR and radar. And then on the service side, we find that the art of working on cars has kind of gone away a little bit. So we spend a lot of time drilling holes into these things at customer sites. We will go to OEMs and install radar in our OEM research institutes. So just bringing that more mechanical aspect to integration, and how do we connect a LiDAR to a car in a research boat to make sure it stays there and it doesn't need to get jiggled around and I need to reverse on it or something. And also amongst the services, helping understand someone's particular application and designing specific things around it, writing software around it. And then on to software, so we're doing a ton of development in ROS, if you're familiar with the robotic operating system. We've got low-level controls, which help the car steer itself like a human would. So you don't have to spend a year tuning the thing to actually drive itself properly. We will give you low-level controls that when it receives a computer command to say, turn to the left, it very gracefully does that as if a person was controlling the car. And then platform. So Fusion and the MKs are basically the same car. One is just a little more dressed up than the other one. We have to use cars that already have with the technology package from Ford. So that means it's already got adaptive cruise control. It has active lane keeping. And what that means, and this is also hybrid. So because it has active lane keeping, it has a little torque motor or a servo motor in the steering column that can steer the car. We can access that motor and use it to steer, have the computer steer the car. It has by-wire braking. The hybrid system, the regenerative hybrid systems always have by-wire braking, so we usually do hybrids. And adaptive cruise control also gives you a brake, by-wire brake booster. And the cool thing about the Lincoln, if you look inside there, there's not even a shift lever. It's got some buttons on the dashboard in order to shift gears. And it's funny, I was watching Cars TV or something this weekend, and they're kind of talking about how much people supposedly hated this feature. It is a little weird to get used to, but the great thing is I can put it into drive with the computer instead of having actually to touch it. And the Ford Fusion doesn't have that, so that's the only real difference between those two vehicles. Is that in the Fusion, you've got to put it into drive and then enter autonomous mode. So, which could be problematic if you moved it out of drive when it was in autonomous mode. Creates a conflict there. And these came out in basically early 2015 or late 2014. And then at CES this year, we released our version of the Polaris Gem. And I mentioned that we had used a partnership really to get the Dbc files and get these things to create an interface for it, but the Gem was our effort to really do that ourselves. And we created our own sort of CAN. CAN bus is the communication system in the car. We created our own CAN controller that can be applied to any vehicle and be used to actuate all its CAN devices. So in the case of the Gem, it didn't have, it's just a regular steering column. We modified the steering column with what we call an EPAS motor or a DC electric motor, and so we can steer the wheel with the computer. It has true by-wire braking. We connected a wire to the brake pedal so we could pull it and apply the brakes. Kind of old school, but it's in fact using the same EPAS motor, just kind of mounted on a piece of subframe, and it's tightening and loosening to apply brakes. We put a capacitive sensor on the brake pedal so it can sense your foot on the pedal and disengage from by-wire mode. And one thing I didn't mention in all of this is these torque motors can sense if you're resisting them. So at any point in time, as you're sitting there behind the wheel and it's driving itself, if you resist the wheel, hold on to it. If I touch the brake pedal, if I touch the accelerator, it instantly relinquishes control and gives it back to the driver. So that's kind of one of those big safety aspects to where there's never any latency in regaining control. There might be human latency in you realizing you need to maintain control, but in these situations we're highly sensitive to what's going on, so there's not that falling asleep at the wheel thing all the time. And then if you want a very fast and fun off-road vehicle that's also autonomous, we do the Polaris Ranger. The main difference is you can drive this in the state of California, you can get a driver's license or a license plate for it. The Ranger, I think it can be modified for road use, putting different tires on it, but I probably wouldn't want to drive it on the road because it's quite tippy. And then the products. This is just a smattering of pictures, but I guess the most famous one here is probably this guy, the Velodyne HDL64. If you think about a foundational technology and a foundational company that really created a lot of this market, it's that sensor and David Hall from Velodyne. He created that sensor for the DARPA challenge after a failed try at using stereo vision for navigation. And as this legend goes, he kind of created this in the back of his then acoustics factory down in Morgan Hill, stitching and soldering together a bunch of laser diodes. And the story goes is, as soon as he plugged it in, it worked on the first try. So he's like, maybe I have a good idea here. And if you see in these images, it produced 64 channels of LiDAR, scanning the environment. It's giving you a great picture of the world, but it's also all of those little points are providing XYZ data in space, reflectivity, and it's robotic eyes, essentially. And that's its baby brother, the VLP-16 sitting on top of my car. And on top of the original LiDARs were these guys. When he's like sick, this is a 2D LiDAR. You would have seen this on the very early Google mapping cars. And of course, the advantage of having one laser spinning around, and it's really not even a spinning laser. There's a mirror rotating around this kind of big thing, steering the laser. The Velodyne's got 16 individual laser channels. In that case, it's 16 as well. Other very important products on here are radar. Radar is probably the most infallible technology. It doesn't care how shiny stuff is. It doesn't care if it's dark or rainy or snowy. It provides a great kind of backup for all the rest of this stuff, many of them being optical type sensors. And then the other types of LiDAR that you might see, this is a more automotive grade that you, kind of like the one I have on the front of this car if you look back at the top, the Aveo Scala. It's just a 4-layer version. It's sort of designed to be integrated into the bumpers. And the big difference is instead of using one of these 360 guys, you're kind of have an array of these sensors sort of built around the vehicle. And then actuators. I guess the other big piece that's always on there is GPS. So we use what is called deeply and tightly coupled GPS systems. So that means we not only have a GPS receiving positional data from satellites, we're also getting RTK corrections either from a base station over radio or cellular, TerraStar corrections over another satellite, and using an IMU as well, an inertial measurement sensor that in the absence of GPS, the IMU tells me if I'm moving or have moved in some direction that the GPS didn't predict. So the deeply coupled is IMU, and the tightly coupled is really giving you the RTK corrections. And in any case, we're always using maybe at least 3 technologies in every vehicle. So almost everybody has radar, LiDAR, and some sort of vision system. The vision systems are either smart systems or dumb systems. Smart system meaning like the mobile eye, it's actually going to identify objects and tell me what they are, or point-and-gray cameras, gig cameras that are just ingesting data, and some smart person figures out what it's actually looking at. So a couple examples of what we do really in the nitty-gritty. Vehicle integration. It's tricky to pull apart this car and run all these wires in a graceful way where they're not going to get hot or wet or interfere with each other. So we really pride ourselves on the work of, especially this is what we call showroom style. You don't see any wires inside of it. It just looks like a somewhat OEM style car, but it's got conduit ported underneath it from the front to the back. It's got wires above the headliner. We've tucked the wires kind of behind the dash for the screen. So we try to make it look as clean as possible. It doesn't really look that way when we're in the midst of integration, of course. So once we've got a fully integrated system, we certainly get into the basic bits of software. So data fusion is a big deal when you've got all these different sensors. So we offer a service where we do the coordinate transfers, i.e. we're telling the computer where all these sensors are relative to each other and aligning them in the computer, so then we get an image like you see on the screen there of perfectly aligned LiDAR. And then what you can also do is add your 2D video to that. And there you can't really see it, but there's also a mobile eye interface there that's telling us some pedestrian is there and then how far away that pedestrian is. So this gives you this really rich view of the world in a digital environment that you can then use to make decisions. We typically don't get to that decision-making point. That's when we're handing it off to a customer to do the hard parts of digesting all this information and figuring out how to drive through this big mess, which is the very good. Of course, when we're delivering a car like this, we're training people on how to use it, giving them all those command sets, making sure they understand what they're getting themselves into. But typically, they're already porting algorithms onto the vehicle the day they pick it up. They're already testing it. So it's always exciting to see. The design and install, like I said, we're always trying to find new ways to gracefully put cameras on these things. So this is our shop manager, Tyler, in Beijing, putting a Velodyne sensor as well as the Carta stencil. This little guy is a Velodyne LiDAR sitting on top of a NIP computer with an inertial measurement sensor in it. And you can just walk around a room with this and it creates a almost survey quality 3D map in real time. It's really amazing and beautiful in many ways, actually. So that's a thing where you can essentially create a 3D map in one pass and then drive through that 3D map, localizing yourself almost instantaneously. So really it's an interesting tool. In our discovery service capacity, we can take different technologies and compare them for you if you're not sure what you need. You're not sure, do I want a mobile eye or do I want to go with a stereo camera? Do I want to use Velodyne LiDAR or something else? Do I need a heavy-duty GPS or can I use something very basic? We can test this, give you raw data, create raw specs with that data, and let you make the decision. And on the consulting side, we do things like a Chinese company comes up to me and says, where do I put the sensors on the vehicle? How do I create a by-wire interface? That's become a big part of our business as you can imagine different companies that just want help on how to actually make an autonomous vehicle with a traditional vehicle, which is always very fun. So I still don't know what BSP stands for. If someone could figure that out, I would greatly appreciate it.
Board support package.
Perfect. So we're kind of existing up here with our middleware. I showed you that data fusion bit. And then above that are the newer bits of software that we're getting into. So a couple, in the early years, we'd already developed lane keeping algorithms, active cruise control, automatic braking, and we're using them typically just to demonstrate the car and to help sell. Nothing is a better sales pitch than me driving someone around this thing in autonomous modes. And beyond that, it's great to just give people that experience. It's really interesting to see the reactions. So, under the auspice of acceleration, if they're really looking for higher level software development, it's much easier for us to offer up these low level software controls, whether that's control or some basic things to get them down the highway, so they can start doing deep learning on vision or path planning or the more difficult stuff. So we're I don't think we'll move much up the stack past here as an enabler, but who knows where we'll go in the future. So I guess in the process, we're typically interacting with people to decide what do they want to do, what kind of application are they approaching? Are they data gathering? Are they going straight for ADAS level 4 or 5? And that dictates what we're going to build and what we're going to sell them. We're then selecting a specific vehicle package. We do semi-trucks now, so that's the entrance where if you don't want a car, we can put together a Navistar ProStar semi-truck in the same amount of time. And incidentally, it only takes about 6 or 8 weeks for us to do this. So this is very much a race, and having these vehicles in your hands in that short amount of time is highly beneficial. Incidentally, we can do that anywhere in the world, as long as you get the car there. And then right after that, we're putting in data fusion systems if that's required. And then the automation algorithms, smoothing out the vehicle control and making it feel better to drive. And then this year, GTC, this car was kind of built for NVIDIA, for GTC. If you went to the CES, Consumer Electronics Show in Las Vegas, This year you would have seen a green and black car driving around in figure eights by itself for many hours, with a guy standing there with a kill switch in his hand, which was insane. The guy was actually going quite fast, going from dirt to pavement and dirt. We had built that car, enabled it for by-wire, and then NVIDIA put their drive PX in it and cameras and had it driving by itself. And NVIDIA's now set us up as a distributor, and this is the Drive PX 2 on wheels, where we can basically put together a kit with the Drive PX, all the sensors that NVIDIA has created drivers to interface with that Drive PX, and deliver it on a vehicle that's enabled by wire. If you talk to Jensen, it's the greatest thing in the entire world. There'll never be anything better. So, but it is a pretty amazing product because NVIDIA, I think, had the intuition to know that, beyond LiDAR, cameras are going to be a very important part of this equation. And with that graphics processing capability, you can connect 6 cameras and do processing. You can connect 12 cameras and do ingest on a single board. If you try to connect that many cameras that are USB 3 or something, it's very difficult. It's very difficult to have the compute to actually do that. So, pretty amazing company, and we're really looking to see great things coming out of that. And of course, to connect to that, we've got the GSNL cameras. It's different than USB 3, the gigabit serial media link. It's kind of a coaxial connection, which seems much less noisy. Connecting that with GPS and different types of LiDAR and radar. And then you can actually get DriveWorks on top of that, which gives you object identification algorithms, gives you safety exclusions and algorithms right out of the box. But you can see how much coverage you get when you have these kind of sensor arrays. And it seems kind of overkill, and I think it'll be pared down as things become more intelligent. But you've got typically 6 or 8 cameras, 6 or 8 radars. And I guess a good example is this is the newer Tesla that's basically doing pretty well with just radar and cameras. Mainly because Elon hates LiDAR for some reason. But we'll let Mike tell that story. So what do you get? So basically, this is a very clean integration. Most research vehicles don't look like that, so clean in the trunk. It's usually 80/20 everywhere and all sorts of computers. But if you really want it, we can make it look like this. We can put colored lights in there. And we're leveraging our 90s stereo installation skills there. We can put lights underneath the car if you really want. And we certainly do modifications. We have someone very recently that wants us to lower a Polaris gem. And we're not really sure what they want to do. We're all for it. So, and of course, with Drive PX 2, we're configuring the cameras here. So if you might not have noticed them, but there's camera mounts up inside the upper windshield of this vehicle with those GSNL cameras, just trying to make it look clean and well integrated. So and again, it's very much turnkey. This is a 6-week turnaround to get this thing out. And this vehicle has both. So I've got a computer hidden behind the back seat there that is actually my by-wire control computer. And the NVIDIA is just doing a bunch of visual object identification out of the windshield. So a more advanced kit might look like something like this. So you've got multiple VLP32s or multiple VLP16s, up to 11 Seconics cameras, an Xsense GPS, or an Autotel GPS. And really, there's a massive range in cost of GPS, and that range gets you from many meters to centimeters of positioning accuracy. And again, you will see a ton of sensors on an individual car, but as they get everything figured out, you need less GPS, you might need a few less cameras, and again, less computers, hopefully. And then with the Polaris, it's the same thing. It's a significant cost savings with it. It's maybe a little slower, easier to drive. It's great if you have a campus or a university, you want to make a shuttle or something. It takes a little more adaptation. We're putting our own little racks on it to mount radar. But it's a fun little vehicle. I think we're a little leery at first. We just got one of these. It's at our shop down in San Jose now. It's actually really fun. People really seem to like it. It makes for very easy integration just because you can pull it apart very simply. But a typical kit on that is going to be, some GPS, a few cameras, and the Drive PX, and maybe ultrasonic sensors or other stuff just to give you close quarters perception if you're going to be operating in an area around a bunch of people. And then, of course, we design them to be anything. If you want the Drive PX and an NXP in the trunk, we will happily do it. We're pretty much agnostic to what goes into these vehicles, as long as the end result is something that is working for an end user. So it's, and we're actually always out looking for new technologies too. So we've always got our antennas up for new LiDAR, new cameras, everything to help kind of get those into the hands of researchers as quickly as possible. And then these are just some fun pictures from race days. So we participate in self-racing cars events as they come up. We do these with GPS path following. We're going 80, 90 miles an hour in straightaways with these vehicles, and the car is driving itself. So if you want to really develop faith in a vehicle, sit there in the driver's seat with no hands on the wheel and around a racetrack. And actually, on closed racetracks, very recently I was working with a TV show called Mindfield, sitting in the back seat, hiding in the back seat rather, with the actor also in the back seat, nobody in the front seats, the car going relatively fast in GPS mode. So, and it's a weird evolution. You know, my first months with this company, having this thing on autonomous mode, it's a little nerve-wracking. I have to be honest. Just watching the steering wheel go, you're kind of focused on just the little bits of stuff, but as you kind of relax and watch it repeatedly perform flawlessly, you quickly become much more confident in it. We're typically not doing object avoidance with it. That's a whole different level of risk, but on a closed course, just to watch it follow a path very gracefully is really amazing. And stop at a very perfect spot. So that's all I've got on as far as slides are concerned. Does anybody have any questions?
Are your APIs public so that somebody could design to them before they bought the car?
Absolutely. As soon as you order the vehicle, we give you all the API information. So when you receive it, you could have already, well, you could be simulating it already, and it's ready to go.
But that's after you order one, so before you order one, you couldn't get it?
No.
Also, at some point, you might be also doing facial recognition technology.
What would you do?
Well, I've registered for a study by MIT on aging and autonomous driving.
Okay.
And so the person who's leading that study really is trying to have facial recognition in cars.
In the vehicle.
The vehicle. For people who might, be overly distracted, might have a medical emergency, and then the car can take over if somebody has like a stroke.
Yes. We don't personally, but there's a huge, a couple of points on that. We work with a company called Urban Ears in a distribution capacity, and they make, it's human factors is the general industry. So they make head and eye tracking software that you can determine where they're looking. That's in the research part. And part of NVIDIA's goal too is to have, of all these cameras in the car, cameras watching us. And the health piece was the first one, right? Are they sleeping? Are they healthy? Are they passing out? Then prioritize some way to get them to the hospital or something. And then secondly, natural language. So not only can they recognize their face, they can read your lips. So you don't have to say navigation, give it an address. You just talk to it like you would talk to a person and they'll understand. So it's amazing the developments in that stuff. So facial recognition is ancient technology actually. But that will certainly be a piece of it. Because when you're handing over that, job to the car, it's got to kind of take care of you. I think that's a nice add-on to really have some more safety and to create a whole other way to keep people getting to the hospital. And then in B2B communication, which is the other part of autonomy, is then all the other vehicles know, hey, this person needs to go to the hospital, prioritize their path there. So, or your car could watch you. They're eating too many burritos. Yeah. The seat can weigh you. I mean, who knows what could happen.
What's your view on the current state of communications on sensor technology? For example, is there no combination of sensors currently that's relevant? Snow or
yeah. I guess my standard answer for that is, if you don't feel comfortable driving in that environment, I don't think the autonomous vehicle would. But So you think about LiDAR, they're all optical. If I splash mud all over that sensor, it's not going to see anything. Similarly with cameras, they're violent relatively easy. Radar is a little less, but the radar is attenuated when it gets wet or has ice on it, so there isn't really a perfect combination. There's no silver bullet. So there's then the dependency on B2B communications, B2I, different positioning stuff that you don't have to depend on the vehicle really knowing exactly where it is. But of course, there's going to be a situation where it's just not going to work. And I think I would never make that discrimination, but of course, in a blinding blizzard, I would just stay wherever I was and drive where I need to get later. Because everything's going to be that way. So, nothing's perfect. I don't think it ever really will.
What's the range of cost for different services, like the drive-by-wire vehicle? How much does that cost?
I don't really get into that stuff, but I'll send you a quote tomorrow if you want. Actually, you get the green shirt.
So for development simulation, what tool chains do you support and what is dominant?
In simulation?
Yes.
Well, we work with engineers, but it seems like Furies and a company called TAS. I think TAS is the oldest player, or at least I was told they're the oldest player in the simulation business. And the tricky part of what TAS has that separates them out from most of the other simulation software stacks is that they're able to simulate sensor behavior in simulated environments. So they can predict what the Velodyne is going to see in a virtual environment. So you can test all these scenarios. So you can imagine gathering real-world data, finding some corner case that you need to solve an algorithm for, bringing that into your simulation, and testing it over and over again until you figure it out, and then maybe adapting your sensor technology to accommodate that situation.
So is Networks got any traction in control of the vehicles, or they kind of left out?
I think they're a little outside of the, that's an interesting, it's funny, I don't think they're really a core automotive player. And I know their simulation and Simulink and stuff but it seems like more real world driver simulators that are specific for that are much more laser focused than MATLAB.
It's not really a technical question, maybe more of an interesting question. I'm dealing with an 84-year-old father who's not really very competent in driving and attempted to buy a car. Where did you go? And I work with Sky.
Yes.
And so he was there, I was like crying, oh my God, he's gonna kill someone. So the question is, do you think autonomous driving vehicles will enable people that are partially competent to drive?
Yeah.
Will it make he has a valid Florida driver's license? They only check every 10 years. He's an advanced cardiovascular. I don't know, it's like, is this gonna help or hinder sort of people in this kind of, and adult children like me that are dealing with it?
Yes, it will absolutely help. And I think that's a key driver, right? So, and it's the main argument that I explain to my parents and older people who don't understand the technology. When you're too old to drive, or you lose your sight, or you're no longer ambulatory, this can drive you around. And I had an interesting conversation with some government people from Australia who were at this AVO show this week. And similar story, he's got an 80-some-odd-year-old mother who is, she can get around, but you wouldn't want to put her behind the wheel of a turbo Porsche and have her driving through the Swiss Alps. So we're imagining the scenario with our little electric golf cart vehicles, right? So she lives in a retirement home, and she has to go to the doctor on such and such a day. So the only thing she needs to remember is that she needs to walk outside dressed with her purse at 10 o'clock and get into this vehicle. And then that'll take her to the doctor and then deposit her back at her house. So it'll certainly provide greater mobility, I think, to people that can't drive, whether that's in a controlled environment, in a retirement at Rossmore or something like that, or in a little further into the future with full-blown cars, where as long as you can actually remember to walk outside and get in the vehicle, it can take you to where you need to go.
from a regulatory standpoint, in Florida, you won't have to get a new license every 10 years.
Yep.
So from the age of 74 to 84 is massive cognitive decline. And they don't, you know, I can report him anonymously. And they have this, well, I was on the phone with them last
Yes.
week. They're like, I have this entire process of how they're gonna check him out.
Yeah.
But I'm like, well, you know, it's kind of crazy. And Florida's well known for elderly people getting
Yep.
in massive accidents,
Yeah.
killing people.
Yeah.
So,
Well, the other thing
your
too-
thing is right, but
Yeah.
it doesn't change the regulatory system.
This is true. And actually, Florida is, for as crazy as a lot of Florida politics is, they are wholly embracing autonomy. And I think that's a big driver for that reason. I had a senator from there just yesterday talking about
I know they changed the every 10-year thing.
Yeah.
Like after a certain age,
Yeah.
or something, things have got to change. Like,
Yeah.
I want to report him right now. And I'm like,
You can report it.
no, I can, but ask God. I was like, I am a courteous person. He's about to
Yeah, yeah.
Okay?
Well, I
He's gonna
know.
kill someone in Coral Gables and settle my name. Okay?
Well, the other thing you could do.
We have to follow our lengthy government process.
Yes, yeah. I mean, that's of course the wrench in the works, but there's a lot of technologies on new cars that can help him survive, even if it's not autonomous, right? Emergency braking systems have saved thousands of lives already. They save billions of dollars because they reduce the total damage in a vehicle just because they can slow it down considerably before an accident happens. And they will avoid pedestrians. So I would recommend if he's getting a new car, to get one with an automatic, like a Subaru or a Nissan that has, yeah, exactly. A nice Nissan Leaf with emergency braking system, active lane keeping, and cameras. So if you really want to get brand
I need to employ this.
yeah. That was a great question.
Oh, hold on. Why not just design a robotic procedure in the driving seat to control all the car? It's like a general control.
A robot to sit in the car?
Yeah, why not? It's easier,
Why
right?
not just put a driver in the car and give a guy a job?
Yeah, but
Oh, yeah, yeah.
easier to design.
Yeah. It would be really expensive
No, it's much easier to design.
to put a, oh yeah, I
And
mean,
then
put
you
a,
can make the more
Yeah.
scientific and more
yeah, for sure. So this is how a lot of systems work in autonomous agriculture. They put a big pizza-looking thing over the wheel of the tractor, and it moves it around. But what if you want to have the car drive itself sometimes, and sometimes you drive the car? Then you have built all this stuff in there that you've got to move, and it's just not really, it's an integration problem at that point in time. But I've certainly seen there's an autonomous motorcycle or bicycle that has a robot sitting on it, driving it around. But to that point, you wouldn't need to build a whole robot in there. You could put an actuator on the stick shift and manual actuator. And I mentioned with the Polaris Gem, we're pulling the brake pedal with a wire. So that's the same thing as having a robot, an expensive, scary robot pushing on something.
You could do it with more control.
Yeah, and then the other part is there's a number of companies, and actually to your father's case. So imagine OnStar, right? You in the GM products, you tell OnStar, hey, help me out with something. The next part is teleoperation, where they can see through the cameras in your car and they drive you to where you need to go. So it's teleoperation. It's not what I call autonomy. There's someone sitting in a room somewhere basically looking like they're playing some game, but they're driving a real car. And I can't mention who they are, but we delivered a car to someone in Palo Alto a couple of weeks ago who within 2 weeks had an interface over cellular network that could drive the car. And he's not an automotive guy. He's coming from like a multiplayer gaming background. And we were amazed because I think interacting with him, and he's very young, and lo and behold, 2 weeks later, the investors are all over him because he's already cracked this nut with teleoperation over cellular networks. This stable. So pretty exciting stuff. Yep.
So on the flip side, do you see then, I guess, younger people who are now getting used to autonomous cars, no longer learning how to drive
Well, that's already happening anyway. So, it's already happening. I think Dave and I hung out at the DMV the other day, and it seems like the age at which kids get their licenses is getting older and older and older. And that's for a number of reasons. There's ride-sharing services. You don't really need to have your own car to get around anymore. And I think there'll be a year to where you'll know when that baby's born, they will never operate a vehicle. I don't know when that year is. Maybe that's now. 16 years from now, they won't need to actually operate a vehicle. But how many people know? I know exactly. How many people know how to drive manuals anymore that are from the U.S.? You know exactly. Here, but if you've never been in another country, thank you. I love it. Stick. And that begs the question too. Like, what do we do with our sports cars when all these things are autonomous? Yeah.
So these sensors are. The radar in particular is pretty exposed to the road.
Yep.
Someone could steal it.
Yes.
To bring this up.
Yes, of course.
It seems obvious.
Yes.
A rock can hit it. Something, a bird can fall on the windshield and screw the camera.
Mm-hmm.
Are you having a plan with your integration to fail gracefully in those circumstances, or is that the responsibility of the integrator who's developing your applications above what you're doing?
Usually, yeah, because amongst their use case, if that happens, so we're giving this to them and indemnifying a little bit, but they've got to deal with those eventualities. So, and then that comes into the piece of sensor redundancy. But those radar are down low because that's the easy place to put it. But the OEM radar are behind the plastic, so they're not going to get any these. And if you look at I don't know if this one has it, but they put heaters in above the cameras, and there's all these new growth of products to squirt water on these things as they go. So, but of course, there's going to be some you drive into or whatever. It's great. And I think the system would have to either stop or control that driver in a real autonomous situation. But yeah, or you have multiples of the sensors crush all of it.
So that's outside the scope of sort of testing.
Yeah. So I mean, exactly. We're at the research level. But we're seeing it already. In fact, we have customers doing autonomous loops back and forth between here and Arizona. And we saw a sensor the other day that it was like just caked in bugs. And it was a really funny one because it was a sensor that we at Velodyne were telling ourselves, oh, because it rotates and it keeps itself clean, and it didn't. It was a good example of like somebody had just beaten the heck out of it and seen that it oh, that's why Google put that little cap on it with that stupid windshield wiper. That was a great idea. So yeah. But yeah, to your point, yeah, and stealing it too. Imagine if I had that $8,000 sensor and I just parked that thing in San Francisco overnight. Yeah, it would probably be gone in the morning.
Nobody knows what they are now.
Yeah, in fact, there's a city in Nevada where they're putting those on every intersection. I won't tell you where. They're getting them green, and nobody knows what they are, but they're monitoring traffic for fields.
How do you see the transition between the current research development platform to the series in terms of software and hardware? Because there is two schools, and we don't see really a synergy. From research platform, you have more and more people using for ROS systems. And on another side, you have the old school automotive industry, which use mainly for development, space systems, there's lots of old school stuff. And we don't see a synergy between these, in terms of software and in terms of hardware also. So how do you see the future of that?
It's a tricky question. ROS, I'm not a software guy, so I can't speak too deeply about it, but it just seems it has been embraced by the development community. ROS comes from the area, it's supported here. It seems that in that environment it's easy to put together sensor fusion, but of course it isn't safety critical, it isn't necessarily real time. But I'm sure there's bits of ROS running on some OEM ECUs in cars today already. So, and even within an integration of hardware stuff, just before this meeting, I was working with a customer who was like, well, how do we make this look nice so it kind of looks like it can be put into a vehicle? A lot of that is just a design aspect of it, like how to integrate them gracefully into it on the mechanical side. And on On the software side, I know Ross is making great efforts towards safety critical ROS, real-time ROS, so they can be a system that can be integrated into the vehicle. So I guess that's all I would. I can hear you.
I'll go first, and then I'll bring it over to you.
Yeah, so you already have a highly integrated hardware platform and also the software to make the autonomous working.
Yes.
Work. So, and when your customer, for your customer, what others they can do? They optimize the
What are they doing on top of it?
Yeah.
Yeah, so path planning. This is the most difficult piece of autonomy in my eye, mathematically at least. So, you know, it's easy for me to follow the path that I've traced without anything getting in my way at speed. But you've got 10 cars going 80 miles an hour that you need to deal with in this very dynamic model, which is path planning. That's what they're doing. So they're taking the data we give them on the road, and they're figuring out algorithms to navigate through all these different situations. So that's, you know, moving through pedestrians in crowded areas, dealing with construction zones. But this is all done in deep learning algorithms. That is, I can't understand, but that's typically what they're doing. They're dealing with the difficult pieces of autonomy, testing it out with this, basically. So that's and making it drive itself. So in its form that we deliver it, you can drive it, you know, very basically, but it's not. You need to do some development before you can actually unleash it into a public road. It'll just survive. So, which is a lot of software programming. So basically, I guess the basic question is they're mainly software.
So coming back to the safety and reliability,
Yep.
I think, like, how long are we going to stay in the research mode where weather and bugs and night mode and wind and snow and all these things, they're not edge cases, right? These are actually constant requirements. So like that's one half of the question. The other half is, as I update my hardware and software, how do I ensure that it's still safe and reliable? You know, I get a new upgraded sensor, or I add a new sensor, or I change the sensor. What is the industry doing about that?
Yeah, those were probably more forward-thinking questions that I could even have to answer. So on the weather one, strangely enough, I think that this colloquial thinking in Silicon Valley corrupts us a little bit because it's sunny and nice here all the time. The roads are flat, the street stands are clean. But our friends in China are dealing with bumpier roads, different signage, crazy weather, and they're figuring it out. So, and it's just a matter of more deep learning. And you know, in the AI world, maybe the bots figure it out for us, which is kind of scary. And then to your calibration question, I don't know. You would hope that it had been tested significantly before they give you that update. And Tesla does that already. You know, when you park your Tesla in your garage, it's connected to your internet, and it's going to keep getting updates that they might not even tell you about. But I'm guessing they're testing those things before they put them on the car. Yeah.
Actually, I'm gonna cut off right now, and you're welcome to come up. We'll have, you can stay for a little bit.
Yeah, absolutely.
And ask questions. But I just wanted to thank you.
Oh, Jesus, so cool.
I got you your very own USC colored Nissan shirt for your next Museum. So yeah, you're welcome to come up and ask some questions. You can hang out around here, probably around 8 o'clock. We might start kicking you out. You're welcome to stay until then.
Awesome.